Can I get some response in chat box? Good evening all. Good evening. So today we will be discussing about the first project, which is going to be traffic sign recognition. We'll be doing with our CNNs, both with PyTorch and TensorFlow. That's going to be the agenda for today's session. Good evening all. Yeah, good evening. Can I get few more response? Am I audible? Can you guys see my screen properly? If I get some response, I could start with the session. Yes, thank you for the confirmation. So we'll be moving towards the particular project. Okay, so yeah, so give me a second, let me just prepare and then start. Fine. So in our previous class, what content we have seen on day 7, we have implemented the CNN, right? We have seen about how to do it in PyTorch and TensorFlow. We haven't trained our model on that. So in this session, we'll be doing all the process. Now, before doing that, let us go for our VNC viewer. The IP has been changed, so let me just project 192.168.2.104. So I'll connect, continue. Yeah, so as you could see, I have been connected to my Jetson Nano. And as you guys know, we can also do it in both ways. So first I'll use this way to first explain the code and working principle of it and all. So once that has been done, we will also go and see for PyTorch separately, so where I'll use the Jupyter notebook, so that I'll directly connect using the SSH, right? So using SSH or some other way are we connecting it? We'll be using SSH for connecting, right? So we could connect and run the Jupyter notebook and the laptop itself, so that we'll do next. So for now, I'll just look at the folder directory which I have. Okay, so this is my directory. So I'm going to change the directory into a folder which is called as home. So I have particular files available with me. Okay, so today, as I told you guys, we will be looking at a project. So I am just happy to first show you guys the outcome. Then later we'll be looking at other contents or how to achieve it and all. Okay, so that will be upcoming contents and all. So first, let us go and look into. I'll do one thing. I'll run Python 3. We'll run the GUI.py. So this has been also integrated with the front end, which is simple tkinter for creating windowed app and all. So this is just for inference. You could also run it directly by running inference. This is just to make the usability ease. Okay, so it will use the model actually. So it is adding the GPU available and all, as you could see. So it would open a particular window for us to run the inference, which a trained model is available. So we'll be using that. So this is the particular app. Know your traffic sign. Okay, so this is a image classification project, as you guys know. I'll be explaining. So you can upload an image. So I'll select an image, for example in test I have a particular image. Okay, so there is this first image, so I'll just open it. So as you could see, this is the symbol, and I can press classify to get the output from my model. So when I press it, it is going to run, and then it will configure and give you the result. So it is actually using the TensorFlow model which has been trained by us. So it will be giving you a result. So it seems like some symbol. So we will look at what class it belongs to first now. Then we look at how it has achieved, what this project is all about now. So see here, the vehicle greater than 3.5 tons are prohibited. Okay. So let us upload another image. So it's actually classifying again, it seems. So the prediction has been made here. So let us go for this image, 10th image. Okay, this is not clear. So let us try some other image. Okay, so this image, right? So let me classify this image. As you could see, the answer is keep right. Okay, so let us try another image. For example, okay, something like the towards right curve ahead or something. Let us classify this image. Dangerous curve. Okay, so that's the prediction has been made, as you can see. So this model is predicting in this way, right? So let us upload the final image and then we look at how this has been achieved. Okay, so this uses the deep learning model. This inference is completely running on our Jetson Nano, as you can directly see. Let us take this image. Okay, not clear for us. Okay, 70, right? So let us classify this image. So speed limit is 70 km. That's what you infer from this, right? So this has been done from the training using CNN, and that's what we are going to infer. Is this project interesting? Can we look into it and see how to achieve it via TensorFlow as well as PyTorch? Can I get some response in chat box? So I'll minimize this for now. So our day 8 is going to be our first project, okay, so which is going to be traffic sign recognition. So that is going to be the project for today's session, traffic sign recognition. So this is a project with multiple classes, and if you understand how many number of classes we have 43 different classes, okay, which means the option, it's not 0 or 1, it's between 0 or 1 or 2 till 43. You have 43 classes, something like dangerous, curve ahead, go slow, okay, vehicles greater than 3.5 not allowed. All these are classes we are going to detect. It's a multi-class classification, right? So in a multi-class classification, in your final layer, what is the activation function you would be using? What will be the activation function we will be going in that? We'll be going for softmax or ReLU or sigmoid in a multi-class classification in my final layer. So introduction, in this era of AI, humans are becoming, someone told ReLU, actually you won't use it in a final layer in a multi-class classification. Why are you guys giving wrong answers? I think we have discussed it elaborately on day 4 itself, right? When you want to select between multiple classes, the activation function on the last layer should be sigmoid, because then only it can use the probability and tell that which is most probable. So which class has maximum value, that will be your output. Yes, softmax is your answer, is the correct answer. So in this era of AI, humans are becoming more dependent on technology. So with enhanced technologies, MNC companies like Google, Tesla, Uber, Ford, Audi, Toyota, Mercedes-Benz and more are working on automating the vehicles, right? They are trying to make more accurate autonomous vehicles or driverless vehicles, and you all might know about self-driving cars where the vehicle itself behave like a driver, doesn't need any human guidance and all, right? So the research is currently going on to make any algorithm to ensure 100% road safety and accuracy as well, okay? So for achieving this, actually we have a certain data set. So if you want to achieve autonomous vehicle, there are a lot of components in it, and one component is going to be, if you have a sign of traffic sign board which is available, your computer or your AI need to understand and act based on it. So if there is a vehicle speed limit of 70, okay, 70 kilometers per hour, that's the maximum limit in this particular place, your AI model should understand that and reduce the speed to that limit. Not only that, we have speed limit, crossing, traffic signals, etc., right? So for making it, we take our first step to train this model. So the first step is the image dataset we have consists of more than 50,000 pictures of various traffic signs, and it includes speed limit, crossing, traffic signals, etc. Like that, we have 43 different classes are present in the dataset for image classification. So the workflow first will be data set exploration we will be doing, then we will do a CNN modeling, then we will train the model and validate it, okay, and we go for model testing. So these are all the steps which we will be doing particularly. So let me just show you the particular project file. So I'll just go into this UI. So we are in our Jetson Nano now. I'll open the terminal, I'll change the directory into a folder home where I have this particular files. Okay, so for example here, let me just show you guys a folder in the name of train. Okay, so there is a folder in the name train. So if I go inside of it, as you could see, I hope it is visible, it is having from 0 till 42, which means totally you have 43 classes. Okay, so for example, I'll change the directory into 0. Okay, so now if you look at 0, you have all these images. Okay, so you have all these images, right? So for example, let me manually open them. Let us go for so in desktop, home itself, I have another folder in the name home where we have it. So if I go into train folder, inside of 0, as you could see, I have a lot of PNG images, one by one I am having. So this is a traffic sign. So class 0, what it is, I'll show you. So as you could see, it is 20. Okay, so it has all my images here is having different images and orientation of the size 20, so that the model could recognize. Okay, so this is the 0th class is actually belonging to 20. So go into the first folder. So 1 has a particular class, you will be having related images of 1 alone. Okay, so what is 0 or 1, we'll see. We have a particular directory for looking at it. So the class 1 is actually 30 speed limit. You have multiple images, orientations of images which represent 30, so that your model could learn. Okay, so as you could see, it has different zoom ranges as well. So it should be more diverse, so that when you give a new set of image, your model can understand and interpret. So I have like this, I have 43 classes, totally 43 folders. Each folder will have a particular class image. Okay, so if you want to know what is what, then actually you have to look at this file. I hope so, a train.csv file will see. There is a particular directory for us to understand. Okay, so this is just the location and file information. So for looking at it, I think we have to look into the meta.csv, or else there is another way we can do it. I'll show you. So it is actually taken from so this is meta path, which is not interested. So let me just show you guys the inference code. Open with text editor. Okay, so this is collected from the place where we have the particular data set. So as you could see, we have mapped between 0 to like from this to that. Okay, so actually the folder are starting from 0 till 42. So here it is starting from 1. Okay, so that later on when we are inferring, whatever the model is predicting, so if it is giving 0, then actually I have to add 1 with it, because, or you can manually change it to 0, 1, 2, 3. Can you guys understand that concept? Because your model will be learning the label as your directory name, which is from 0 to 42, but this has been given just 1 to 43, one step ahead. So whatever the model prediction is doing, okay, so see here, whatever the model is predicting, if it predicted as 0, we don't have 0 in this directory, I just add with 1. So it's just add with 1 so that it could properly correlate with the prediction. So this is the classes 20, 30, 50, 70, 80, then end of speed limit 80, then you have no passing, yield, stop. So for all these we have folder in that name -1. So if you want to go to the folder of keep right, so this is 39, but that is from 0, so you have to go inside 38 folder to look at the keep right images. So like that we have images available, and this is the information about it. Okay, so all these things are now available. So let me just come out of it. Okay, so the first step is done, right? So we have a data, so we have a training folder which has all these data. So you want to train your particular model, so I'll use vim traffic sign.py. okay, so I'll explain. So this is a file which has been from your, okay, not this, yeah. So as you could see, this is a file which we have, which has the training part. code and all. Here we have the CNN. So can you guys tell me what language is this, whether it is TensorFlow or PyTorch? Based on your answer I could guess whether you are clear or not. Okay, so give me some answer whether this is PyTorch or TensorFlow code. By looking at the model creation you could directly tell whether this belongs to PyTorch or TensorFlow. Can I get some response in chat box? TensorFlow, right? It belongs to TensorFlow code. It's a TensorFlow code. So first we'll do this TensorFlow interpretation, then we'll see about the PyTorch to achieve the same thing. Okay, so let me explain. So we have imported NumPy, Pandas, Matplotlib for image based task, CV2 for image processing. Then we are importing TensorFlow as TF, pill for handling image. We are having OS for getting the folders and make it work. Okay, so then we go for sklearn model selection for train test split. Then we go for to categorical to convert your folders into categoricals. Then we go for sequential and load model. Then in layers, as you know, we have convolution layer, 2D, max pool 2D, dense layer, flatten layer, and this dropout is new for you guys. I'll explain what is dropout. Okay, so with this, let me go on into the next step, which is going to be, first I am creating two lists. One is for data, another one is for label. Okay, so the total number of class, as you know, it's 43. So first I am getting the current path, which is going to be, if you call OS and use .get CWD, which is get current work directory, it will give you the path of current working folder, which is inside home. We are there. Okay, then for in range of class, for example, if I have 43 class, it is going to run 43 times. Okay, and then what it is actually doing is, it is going for os.path.join your current work directory. Then along with that, it's joining the path, which is train, and then string. Okay, string of what? String of I. What will be I? I is going to run for range of till 43. So it starts from 0. So first it gives the folder pathway for 0. Then once this is done, it will go for 1, then 2, then 3, then so on till 42. Okay, so that you could open all your folders. So first it opens 0th folder. Okay, so you are just getting all the image names inside of it. So using os.list directory of this path, you get all the image name in a list. So for all images, for in images, what you are trying to do is, you are opening that particular image. So you get the path of 0th folder, and then what's the first image? First you are opening and then resizing it to 30,30. Then we are transforming it into an array, and then we are just adding that into your data folder. We are just appending. So inside a list, we create 2D by adding all the features or the matrix. Okay, so for what's the label? What is I? I is going to be 0 or 1 or 2, which is the class or the folder name. So I just append to the labels folder now. If there is any exception, it is going to print that. So first this will do for the first image in 0th folder, then this loop runs for the second image, then third image, fourth image. So how many image you have in the 0th folder, that will do. Once this has been completed, this inner loop ends. So it go and pick the next I, which is going to be first 1 folder. So inside 1 it will do all the images, so store it, then 2, then T, then till 42 it will do. So from 0 to 42 you will get all your labels stored in labels, and data, which is the image matrix, in data. So I'll transform all these things into NumPy array of data and labels. So once I have it as an array, I could go for train test split. Okay, so in train test split, what we do is, we are splitting 0.2, which is 20% of the data randomly picked, okay, for testing. Okay, remaining thing will be available for training. So randomly it will pick 20% of the data. So total, if you have 1000 rows, 800 rows will be for training. So 200 randomly picked rows will be taken for inference and testing. Okay, so that will be loaded, and you will be having your training images in X train, training label in Y train, testing images in X test and testing labels in Y test. So we have to convert it into one hot encoding, which is 0 or 1. So we use two categorical from TensorFlow Keras dot preprocessing. We have imported it here, right? So we from TensorFlow.keras.utils we have imported two categorical, and we are going to use that now to convert it into binary 0 or 1. 43 columns will be created, because as you know, I told earlier, right, we use one hot encoding to transform each columns when you go for a multi-class classification in this. Then we go and build the model, which is sequential. Okay, so model equal to sequential. So first layer, what layer I am adding? Can you guys tell me what's the first layer we are adding in our stack? And in the meantime, guys, so if you want to convert this masterclass into 1 month certified internship on NVIDIA with AI, you could join and get certified as NVIDIA with AI. So you would be getting 30 days of recorded sessions, 30 days of PPTs, 10 exclusive project codes, VIP community group for doubts and internship updates, IETE internship confirmation letter, 90 days of LMS course access, assignments and tasks, weekly live sessions, resume building mock tests, internship and participation certificate for you to learn and get benefited. So if you want to avail all these benefits, you could still join. The last date for batch 2 ends on 27th. So whenever, how quickly you are joining in the batch, you would be getting the weekend sessions without losing anything. So the original fee is 1,999 and the discounted fee is just 999. It's a limited offer. The batch 2 ends on 27th. The link for registration will be posted in chat box. It's available in description as well. So if you guys are interested, you could make use of it and get this benefits by joining the internship. Yes, very good. The first layer is convolution 2D layer. Okay, so when you go for this 2D layer, what is the particular? So we have a convolution 2D layer with number of filters we need is 32, and kernel size first I am going for 5x5 layer. Activation is ReLU, and the input shape is going to be training shape from 1 till the end. Okay, so once this is done, I go for convolution 2D next layer again. So you can stack like this. Okay, so I am having first convolution layer, then the next convolution layer, then finally I am going for max pool 2D. Okay, so this same, then we go for 2, max pool 2D layer. Then we go for a dropout. So what is dropout? Actually, when your model, okay, can perform or undergo something known as overfitting. So can you guys know what's overfitting? So overfitting is a term which denotes that when your model learned too much on your training data, when you give a new set of test data which is new for it, it is going to give improper results, because whatever it has learned in training data, it has learned too much. So when you give new set of data, they are confused. Okay, to avoid it, you don't want to overtrain your model, and for avoiding it, we add this dropout layer. And as you could see, we go for a dropout of 0.25. And what this 0.25 is telling you is, you are nearly going to lose 25% of what the data has been learned. So you are just dropping it so that you are not overtraining it. Every time this passes through, it loses 25% of what the data it has. Okay. Then we go for another convolution 2D, then max pool 2D. Here we go for filter of 64. But we go for a kernel size of 3x3, and then again the same max pool 2D, then finally we have dropout layer, then finally we have flatten layer with us. So once flatten layer is achieved, I could go for dense layer with 256, activation is ReLU. Okay, then I'll go for model.add dropout of 0.5 finally, then finally I have a final layer since I have 43 classes. So you could add max pool anywhere, but preferentially after max pooling layer, you could add dropout anywhere. Mostly it will be added. Convolution means better to do next process after another convolution or max pool. So after that you could add dropout. See here, in between my artificial neural network, my fully connected network, I could also add dropout here as well. So in our previous examples as well, we could also go for dropout to avoid overfitting. So this is my final layer. So since I have 43 classes, I am asking for 43. because I'll be getting a array of 43 values, and then I could use activation softmax to decide which is most probable. Okay, then I want to compile the model, so I am going for model compiling with loss value is categorical cross entropy, optimizer is Adam, and the metrics I am going to use here is accuracy. Okay, so accuracy is the metrics. So the number of total epochs it's going to run is 15. So I am just fitting the model. So the code is model.fit. So I need to pass the xtrain and ytrain data for training, and batch size is 32. Number of epochs is the number of epochs, which is 15. Validation data is xtest and ytest. So once all these things are done, it is going to save the model file as my model.h5. So h5 is the extension for TensorFlow models. If you want to save, you just need to call your model to save. So what all new weights and bias, it is just going to save it in the h5 file. So once that has been done, we are creating some plots to tell. It is actually in this history. When the model trains, you have the loss calculated and accuracy calculated. So you can just access this by calling history.history of accuracy, history.validation accuracy and all. So then you could go for plt.title, and we are just showing the graphs of what's the loss, how much accuracy has been improved or decreased. Okay, so finally we are making some inference and saving. So this is the entire code for saving. So when you run this code, remaining is for testing, 0.2%, 80% is for training, remaining 20 is for testing, randomly picked to 20. So this code will execute and it will create you some nice graphs, and you also able to get the model h5 file. Okay, so if I look at ls, I am not going to run it here because as you guys know, we use Jetson Nano for inference, not for training. So if I run training now, I have to just manually remove the USB plug power supply for Jetson because it will stuck and stop. It can't handle that much. Okay, so other way, if you have other huge architecture like Nano, Orin Nano and all, you could train in that. So as you could see, I have a file in the name .h5 extension, traffic classifier.h5. So this has been generated, the model file. So I could use it for inference. Okay, so there is a inference code and all. For example, so there is something known as trial.py, right? So if we just look at trial.py. So this is a trial file. So what it does is it makes inference. Okay, so see here, this is not something like you have the model. So I am using load model. So this load model is actually from tensorflow.keras.models. You have load model. So if you use load model, you could load the h5 file. It will support training. Okay, so when I run it, it will support, but it will hang. And the reason is the RAM size is less, the number of images we have here is high, the data is high, so GPU and CPU can't handle that much load. It is going to just hang. So if you guys want me to do it, I can do it. Is going to just waste our 5 to 10 minutes of time because it will stop. I have to just reconnect and freshly boot. So if you guys want, I could just go and do it. Okay, anyway, so we have classes right now. So model is available, so load model. When you pass h5, it is going to load the model, and you have the different classes available with you now. So you have a dictionary, so that whatever model is predicting, 0 means I just need to add with 1. So I can correlate and find what class it belongs to among this 43. So this is the final thing. For example, this is a code for opening the image. So you are just getting the path from the user. It's a function. Okay, so the file will be open. It will be resized because whatever you have trained in the same way you have to give 30,30. You have to resize. And earlier we have trained our model with additional dimension, which is the batch 32 batch. But here you have just single image. So you just need to use expand dimension. So if your image has a size of 30,30,3, when you perform expand dimension, it is just going to add one dimension extra, which means your output shape will be 1,30,30,3. So just extra dimension. Then we are transforming it into array. We are just printing the shape of it. Then we are just getting the model's result by calling model.predict. You are passing your image inside and getting the result. we are printing the result, and we are using argmax to find which is the most probable, and whatever the prediction is, we just add with 1 and we are printing it. And then you can actually use classes, your dictionary, to find what sign it is, so you'll be getting the result. So this is a function which is called as classify. Okay, so here the function, when I run this, it will get the entire input path. When you paste the path, it will classify and print the result in classify path. Okay, so for example, let us run a particular example. I'll quit it and run this trial.py, and before that we need a path, right? So for example, let me take image. I'll get a path of image inside test. So can we try this image? First we'll see what it is, then we just give this particular path. I'll let it load actually. Jetson Nano supports training. Actually, in day 5, day 6 and all, I have shown you a sample code training, right? Or using PyTorch and TensorFlow, we have manually seen how GPU is utilized, how much GPU and all. It will train, but it can't handle image data of this size. It will just use all the CPU cores and then stops. You could also try it at your own risk. Okay, so this, okay, I will try with this image. This is a 9th image. Okay, so I'll get the path which is inside test, right? So anyway, we'll try. I'll go for Python 3 trial.py. So it will first ask for your path. Okay, so it is inside test. Let it load the model and let it be ready so that we could ask it for prediction. Yeah, so it is adding the GPU now for inference. This is called as image classification. Out of 43 classes, you are classifying. So it's asking for path. So it is inside test folder, and I think it has how many zeros? I don't know the particular path. I have forgotten. We just check. Okay, not this. 1, 2, 3, 4 zeros, then 8.png. Okay, 8.png. So as you could see, it has expanded the dimension now 1, 30, 30, 3 reshaped. Then now it's making prediction so that it will print what's the result and all. It runs both for CPU and GPU, same code, because TensorFlow automatically detects and then finds what it is. Okay, so this is what the prediction has been done. So this is the class it has been predicted. I think this is a model which has been, I tried to train here, so it has replaced, I hope so. Let us try to use another model which is I trained in a different system. So I'll just first go back into the home directory. So I have the classifier, right? So I'll just copy traffic classifier into home directory. Next we will be looking at the PyTorch as well, so please wait before we close the session. Okay, so I have tried to make a training out of it, so it has created a model dummy, I hope so. So we have another file which has been trained well, so we will make inference with the help of that. Okay, so enter path, it is inside test 8.png. Okay, so road work is what the prediction has been done. We'll try for another image and then we go into the next one. So this, if you know tkinter, okay, which is for creating UI application front end with window and all, in Python you could just integrate the same thing into what I have shown at the beginning of the session. You can create a window and then you could place a way to open the image for the directory and then showing the result and all. You could go and make use of it. Okay, speed limit 30 is what the prediction has been done. We have to fine tune the model, train it, we have to look at the accuracy and loss to finally conclude how much it is performing, great or bad. Okay, so as you could see, this is the 30 speed sign, the 0001.png, and this is what my model has also been predicted, speed limit 30. So are we clear with this inference? Can we move and look into PyTorch output, or how to achieve the same in PyTorch? Can I get some response? Can I get some response in chat box? Are we clear till now? Also guys, you can convert this masterclass into 1 month certified internship on NVIDIA with AI. So when you join, you would be getting all these benefits from our side, which includes 30 days of live sessions, 30 days of PPTs, 10 exclusive project files for download, VIP community group for doubts and internship updates, IETE internship confirmation letter, 90 days of access to LMS course, assignments and tasks, weekly live sessions, resume building and mock tests, internship and participation certificate. All these things you could get it in a discounted fee at 999. The batch 2 ends on 27th, which is by this Saturday it will be ending. If you guys are interested, you could register by clicking at the link which has been posted in chat box, and you could make use of it and get benefited. So the discounted fee is 999. It's a limited offer available for just few days. You could still join batch 2. The link has been posted in chat box. So when you join, we give you PPT, the Linux commands, code file, the data set for these projects, downloadables, model file. All the contents will be provided for you for your learning and your improvement. So you could get all these benefits by registering in the link which has been posted in chat box. It's available in chat box and in description as well. So the attendance link has been posted. Those guys are here for attendance. Please make use of it. So now we move into the inference of PyTorch. So we'll be learning now about PyTorch. So I'm going to explain in Jupyter Notebook. So let me just show you guys the screen. Okay, so we'll try to have a full screen. Fine guys, so as you could see, we have imported Torch and Torch Vision. Okay, so also in PyTorch the tasks can be easily done. Instead of getting the current work directory and all, we could also use these image folder. So as you guys remember, yesterday, day before yesterday, we have seen our data folder, right? So that will load the image path and all. It will get and make use of different batches. And if you have any folder of images, then you could take from Torch Vision. You could use datasets and you could import image folder. Okay, so I want to perform some pre-processing in the image like resizing and all. So I go for transforms. Okay, then I am calling this transforms to compose some transformation. So the first transformation I am doing is turning every data into tensor. Then I am normalizing. So what does this normalize and all? From next session onwards, we are learning the computer vision or image processing basics. We'll learn more about these properties. So then finally we are resizing it into 30 cross 30. And then this is the transformation. So I am applying it here. So this image folder from datasets, I am passing the train folder. It has 43 folders, 0, 1, 2 till 42. For all the folders, it will just do this transformation. Okay. So when I just run it, first I'll clear this outputs and then run it, guys. So first I have transformed this, right? So all this now available in image folder. So in this image folder, you can call this classes to index. As you could see, you have all these folders, right? It has created classes out of it. And what it will do is it will also encode it into numbers. So if you have a folder in the name of cat, dog, horse and all, it will transform them into 0, 1 and 2. So it will do automatically. So here, since we have it as 0, it's giving you 0 folder is given as 0, then 1 as 1, but 10 has been confirmed as 2. So like that it will automatically transform. Okay, then we can use the data loader and pass this image folder with batch size of 32 to load it into batches. So now you could see I could use this data to look at enumerate and next. Okay, so when you run this, you get, so for every batch you are having the particular label and then the tensor image. So if you want, I'll show 1 of, okay, 0. So this is going to be looking at one batch. So if you just look at the shape of it, you get 32, which is the single batch has 32 image. The 3 color channel, 30 is the height and 30 is the width. So like that, every time you run, you get different batches. And then we are importing torch.nn. So see here, we have to perform a calculation like we did in previous class. Let us see. So we are creating a CNN model. Okay, so first convolution layer 3,32 with kernel size of 5,5. And then here convolution 2D. So from 32, it will create 32 again, same. Then I am also declaring a max pool layer with 2 cross 2, which I will be using. Then convolution 2D with 32. This is the third convolution layer. It will get 32 as input. It will generate 64 as output. So from 64, I am generating 64. So I am creating a dropout. And then I have my first linear layer. So this 3,3 is actually calculated from the formula. So it is 3 multiplied by 3 multiplied by the 64, which is the output. So how am I calculating this? 3 is the height and 3 is the width. I am doing it from this particular formulas which is available here. Okay, so look at this. So your height input is 30. Okay, then width input is 30. So whatever layer you are passing, you have to calculate. So if you pass max pool, so you have to calculate from here. So when you imply, like last session, if you have something like 4.5, you have to perform floor division to calculate the height. Here when you calculate, you will be getting something like 3.5. So the answer will be 3 because it will perform floor division if you have 0.5. Okay, so when you calculate, if you have in decimals, you have to go, if you have in float values, you have to perform floor division. So the parameters is, you have to find it in research. You have to optimize and try with different combinations. By looking at previous examples, you could see and set. So with this formula, you could finally calculate. So the flatten layer formula is height output, width output and color channel flattens to 1D. So from what I have calculated, if I go through my steps, I will be getting 3 as height, 3 as width. So 3 multiplied by 3 multiplied by 64, which is the answer I am asking here. So that is flattened. So that will be the input. It will generate 256 as the output. So from 256, I am getting 43 in the final layer. So my first convolution layer, I am applying ReLU. Second convolution layer, I am applying ReLU. Then the max pool layer. Then third convolution, ReLU. Fourth convolution, ReLU. Then max pool layer. Then flatten. So I have forgotten to add the dropout. So you could also go for dropout in between these. Okay. For fully connected one layer with ReLU, then fully connected 2 layer with ReLU, finally it will return X. So CUDA if torch.CUDA.is available, else it is CPU. Okay, so if you want, you could check out the device, it will be anyway true, so it will be our CUDA. It is CUDA. So I am pushing my model to CUDA. Okay, so now it is allocating in CUDA. Yeah. So once it has been done, I am creating a loss function. Since it's a multi-class classification, I am going for cross entropy loss, and the optimizer is Adam, and I am passing the parameters. So this you could run for 15 epochs in general. For now, okay, after when you are training in a device, you can adjust and then see whether at which epoch the loss is decreasing and accuracy is increasing. So as you know, it will go and get in enumerate, you are getting the batch index as well. So first batch, second batch and so on, I am getting the feature and its respective label. Okay, so for each feature and label, I am moving it to device so that they both can do on GPU. So it will be working on GPU. So I am making a prediction by getting the model's output, and I am setting the optimizer to 0 gradient, calculating the loss by passing loss function, prediction and the label, and then finally your loss function dot backward to calculate, and then optimizer to make a step, and it will print batch done. So this will be doing every time till you complete 15 batches. finally you have option to save the model. So here if you want to save, you can just call torch.save and pass your model's state dict. So what is the state dict will give you is, it will give you all your learnable parameters. Okay, so that's what your output will be. So I'm not going to run this training now, it will cause collapse. So when you call your models to state dict, it is going to give you all your weight and bias of each of your layer. Can you see? So I am storing, this is what the history is, right? So you want to save all these things, it will be saved. So once it has been saved, I can make inference out of it. Here I am loading the model. So you could load by calling, you have to create a model, the class, and then you can call load state dict, because when you create it will randomly initialize, but when you load the dict and pass the values, it will adjust to whatever training you have done. Okay, so this will compose, it will get the image. For example, I'll go for first PNG, but this is not trained. Okay, so this PyTorch model I didn't have the time to train it. So if I have trained it, then it will make a correct prediction, otherwise it can give you wrong answers. So we'll just try to see whether it is able to make predictions or not. So this is how we train and get inference in PyTorch and TensorFlow actually. Yeah, it has been predicted as class 34. So I like that I can use that dictionary to make inference, but this PyTorch has to be yet to be trained. It has to be trained for a long time. I'm just enough to run it for nearly 1 epoch. So you have to train it more so that it can make inference. And for the internship users, I'll be providing the best trained model as well. So that's it for this session. This is how we can create this particular project both on TensorFlow and PyTorch. We have seen with two famous libraries, and that's it for this session. So yeah, so still you can convert this masterclass into 1 month certified internship on NVIDIA with AI. So if you join, you will be getting all the benefits, 30 days of recorded sessions, PPTs for download, this code file, model file, dataset downloadable, all the trained model files, okay, code commands, VIP community group for doubts and internship updates, IETE internship confirmation letter, 90 days of access to LMS course, assignments and tasks, weekly live sessions, resume building and mock tests, internship and participation certificate. So you could get all these things if you join, and by using the link which has been posted in chat box, available in description. The batch 2 ends on 27th. So if you guys are interested, this is the last date for batch 2. You could still register and get all these benefits at a discounted fee at just 999. So the link has been posted in chat box. So we'll see that. Thank you. We'll see on next day, which is day 9. We are going to start with basics of image processing. We have nearly 5 days, because when you want to work with lane detection or object detection, you need to have solid knowledge on image processing. So we'll be looking at that, and we'll be implementing in Jetson Nano as well. Okay, so we'll see that. Thank you guys. Thank you.